Hi everybody, we're going to do this pulley lab here, and this is for especially the G2 guys that will be missing class. But what we're going to do is we're going to set up these three different pulley systems, and if you notice I got a block that's on a pulley, and I'm just going to measure the weight of this block first. So when I pick up this block that you cannot see right here, there we go. When I pick up that block with my scale, you notice it's reading about 0.9 newtons, and so I'm going to put my 0.9 newtons right there. And then it says wrap the string around the pulley like it says in picture A. I'm going to give this, thank you so much for holding that. You're just going to sort of get a good picture of this for me. And so I'm going to put this block on this pulley right here, okay, and try to lift it up with the scale. And so when I do that, if you notice, when I lift it with the pulley, it's still measuring 0.9 newtons. So a lot of people will say, well, what's the big deal about using a pulley if it weighs just as much when I'm using a pulley as when I don't use the pulley? Well, the good part about a pulley is the fact that I get to pull down. And so gravity's doing the work instead of my muscles lifting it up. So if you look back here at the worksheet, thank you so much, it's right there. If you look back at the worksheet here, it says wrap the string around the pulley 1 and record the mass. Well, I put in 0.9 there. It says, why does this pulley make work easier? And it's because you get to pull down with gravity. Now, when I pull the load up 10 centimeters, I also have to pull my hand down 10 centimeters. So if you look right here, I'm going to put this ruler stick right up next to the pulley system there. So if I take my fingers here, and I'm going to start right at the, there we go. Let's start right here at the 80. When I pull down to the 90, if you notice, the block goes up to the 80. So once again, the block is going up the same amount as I pull down. So right here where it says pull the load up 10 centimeters, the block, I also have to pull the string down 10 centimeters. Then it says, what's the mechanical advantage? Well, the force out is always going to be the weight of the object. So part 1 up here where I'm pointing is always going to be the weight of the object. That's going to be the force out. And the scale reading is always what's going to be the force in. So if you take the 0.9 newtons divided by the 0.9 newtons, you get a mechanical advantage of 1. That means it's the same amount. It's not any harder or easier to use the pulley, except for the fact that gravity does the work instead of me. Now you also have to find the efficiency. Well, efficiency is work out divided by work in times 100. So work is force times distance. I'm going to take the 0.9 times the distance out, which I got was 10. I also put in 0.9 newtons and put in 10 centimeters. So 0.9 times 10 all gives you 100%. Now, if you notice, it says, what is the ideal mechanical advantage of the pulley? If you notice up here, there is one string pulling up on this pulley. One string pulls up, so therefore the mechanical advantage is 1. This string over here is pulling down, so you don't count that one. Now I'm going to set the pulley system up a little bit differently to where the block is hanging from the pulley and I have 2 strings pulling up. So I'm going to get you to hold that for me right here and see how I set this up. So I'm going to switch this around so the block is now going to be hanging from the bottom of the pulley like this. And this is going to get a little hard to set up. Boy, I wish I could pause that video. So now, sorry, I know I'm being tricky on you here. So I'm going to now pull the pulley up like this. Well, if you notice that block weighed 0.9 newtons, come over here for a second. Now when I look at that, the weight on that is about 0.6 newtons. Now here's the deal. I have 2 strings that are now pulling that weight up. So I'm going to divide the weight of this block into 2. This string holds up half and this string pulls up half. Well, you would think that would only weigh, 0.45 newtons because the whole block weighs 0.9. Well, the reason why it's not exactly half is this. We still got to lift the pulley's weight. So the pulley adds a little bit more weight to it. Now, the other thing I want you to notice is this. I get to use half the force to pull it up, but I got to put in twice the distance. So my finger is going to start up here at the 50. I don't know if you can get a shot of this or not. But when I raise my hand up to the 30, that means a difference of 20. Okay, so I'm raising my hand up 20 centimeters. The block down here, I don't know if you can get a shot at that down there. The block only went up 10 centimeters. So the block goes up half the distance of what I pulled. Now here's the reason why. not only does this string here got to pull up with 10, this side over here has to pull up 10 centimeters to get that block to go up 10. Well, if both sides go up 10, that's a total of 20 that I got to pull the string. So once again, the block goes up half of what I actually pull, right? And so let's come over here and do these questions real quick. You're doing great. Thank you so much. And so now it says wrap the string around one pulley and record the mass. But once again, it's not the mass, it's the force. The force is now 0.6. And then it says, why does this pulley make work easier? Well, what I did is I divided the load between the two strings. So if you notice up here, this string pulls up with half and this string pulls up with half. Number 10 says pull the load up 10 centimeters. How far did you have to pull the string? You had to pull the string 20 centimeters. So once again, you're pulling twice as far as the load goes up. Well, let's get the mechanical advantage of that. Mechanical advantage, the force out is still the weight of the block, which was 0.9, but I only had to put in 0.5 or 0.6, something like that. And so if you divide the amount of weight of the block divided by how much you put in, you get 1.8. That means it's 1.8 times easier to do the work. The efficiency is very, very similar to that. I'm going to take the force out times the distance out, divided by the force in times the distance in, so you get felt out over finned in. And somebody's having flashbacks here. And that ends up giving me 90% efficiency. The reason why it's not 100 is because I had to add the weight of that pulley and pull that up too. Okay. Now we're going to look at the ideal mechanical advantage. Well, if you look at this, do you see how there are two strings holding up this mass? Both of these strings pull up. So since both of them divide the weight, I have a mechanical advantage of 2. Now the next one is the hardest one to set up. So let me have you hold this phone real quickly one more time. This time, I'm going to have the block still hanging from a pulley, but we're going to end up wrapping it around twice. So I'm going to start up here. Pulley's going to go through, that wasn't good. Let's try that again. I'm going to start right here. Pulley's going to go down through this one. And go back up through here. See if I can make this work. This is always a tricky one to set up. Now, what's great about this one is this. I don't know if I can get a close-up view. When I put the weight on it, once again, I'm getting about 0.5 for my the weight of the scale. Don't forget that that block weighs 0.9 newtons. But here's the good part about this. I have two strings pulling up. It's two strings are holding up the mass, but I get to pull down with gravity. So not only do I divide the force, but I also let gravity do the work. This is called a block and tackle. Same thing as before. If I want to lift that block, let's see if I start on the 7. I'm going to start on the 70 on both of them. Okay, you are doing fantastic. Okay, if I lift that block up 10, so my hand's starting on the 70. I'm going to lift that block up 10. My fingers go down to the 90, so my fingers moved a total of 20 centimeters, but the block only went up 10 centimeters. Once again, I had to pull twice as far because the strings on both sides of that block both had to go up 10. So it's a total of 20. 10 for this side, 10 for that side. The block goes up 10, but I had to pull 20. So let's do the last part here. Thank you so much, and you're done. You're awesome. It says wrap the string around the pulley. Once again, I got a force of 0.5. Some people got 0.6. Why does this pulley make work easier? Well, you have two strings dividing the load, but also I get to pull down with gravity. So two strings dividing the load, pull down with gravity. If I pulled down up the load 10 centimeters, I had to put in 20 centimeters. If you notice, it's exactly like the last one we just did. The mechanical advantage is force out, which was the weight of the block, which is 0.9, divided by the force in, which is 0.5. That gives me a mechanical advantage of 1.8. Once again, it's still not 2 like you saw the two strings pulling up because we added the weight of that pulley. So that made it a little bit tougher for us. The efficiency, same way, it's felt out over finned in. So we put in the 0.9 times 10. That 0.9 is the weight of the object. The 10 is how far the object went up. 0.5 is the force I had to put in, but don't forget I had to pull up 20. So that gives me a total efficiency of 90%. The ideal mechanical advantage, even though the actual is 1.8, the ideal mechanical advantage is still 2, because if you notice on this one, I still have these 2 strings pulling up. This one here pulls down, so you don't count that one. These 2 strings right here are what holding the weight up. So, once again, the reason why I don't get perfect efficiency is because of friction and the fact that we added the weight of that pulley. So how does the actual mechanical advantage compare to the ideal? It's usually a little bit less because of friction or you're adding weights and pulleys. And then in both B and C, what element is sacrificed so that the machine can use less force? You always have to put in more distance. So the whole point of how machines work are you use the more distance so you can use less force to do the same amount of work. Hope that helps. Love you. Bye.